Hopefully you've had a chance to try this problem out. I'm going to walk through the solution. So we have an acid and a base, and we're just going to predict the products for a neutralization reaction and label the acid base, conjugate acid, and conjugate base. So looking at this, I'm going to first try to decide what my acid and my base are right off the bat. And so there are some little hints to how the chemical formulas are written. Because it's tricky to figure out if something is an acid or a base, we have kind of a method of going, hey, here's an acid. And it's to write one of the acidic hydrogen separate from the other hydrogen. So you can see here in this first molecule, I've written CH2Cl CO2H. This is a big old thing, right? I actually drew it so that way it's easier to really visualize what's happening here. And so this hydrogen right here that's bonded to the oxygen is most likely our acidic hydrogen based on it having that oxy acid look, right? It's a carboxylic acid. So that hydrogen's right here in my chemical formula. Now, like one way to write this out would be to say, like if we were trying to simplify this as best we could, this would be C2H3ClO2. And so by writing that hydrogen separately, we're indicating that it's an acidic hydrogen. And so when you see these structural formulas where the carbons aren't all added up together and the hydrogens aren't all added up together, there's more information that is being told to you. And it's usually the order things are being bonded. And so this hydrogen you're being told is bonded to an oxygen that's bonded to a carbon. And that's that carboxylic acid kind of structural feature. All right, so that being said, what we have here then would be our acid, which I hope makes the other one our base. And looking at it, we can see that this nitrogen is the big tip off. It's a nitrogen that isn't positive. That's a big tip off that we're probably looking at a base, especially because the other things I see are all carbon and hydrogen bonds or carbon-carbon bonds. And so that lone pair right here on the nitrogen is going to be our basic lone pair. And so what's going to happen here is this hydrogen is going to transfer from my acid to my base. And so when I write out my products, I'm going to write out my acid without a hydrogen, and I'm going to add a hydrogen to my base. So just writing this out, I'm just going to copy what I have written in my reactants and just eliminate that hydrogen that's at the end. So CH2Cl CO2. Now, it was a neutral molecule, and I removed the hydrogen and left behind its electron. So it's going to have an overall negative charge now. So I'm going to give it a negative charge. It's a terrible thing. So now I'm going to write my base, but I'm going to write it with a positive, or sorry, with an extra hydrogen. So that'll be my NH, and instead of NH, I'm going to do NH2. And then I'll put my CH2CH3 2. And that, again, was a neutral molecule that I've just added a proton to that had a +1 charge. So it's going to have an overall plus charge. And now that acid, what is left over, it now has this negative charge on an oxygen. That's definitely a base now. So here's my conjugate base. And then I have my base becomes my conjugate acid. That nitrogen now has a positive charge and no lone pair, so it's not going to be able to act as a base anymore, but it will have an extra hydrogen that it could donate to a different base.